the lecture. All right, so this is our lecture 2, first week. So we're going to continue our review of the AC/DC signals and then followed by some circuit analysis skills. All right, let's see the PowerPoint slides. We have discussed the signal A and B last lecture, and our conclusion to signal A is purely AC. Okay, remember the category. Okay, we have 3 categories basically: purely AC without DC, purely DC without any AC, or the mixing between 2. Right. So the conclusion for signal A is purely AC without any DC. Without any DC. And the concept we learned is how to judge this is to find out what value. All right, thank you, Daniel. Good. Refresh your. So any trouble of hearing me or seeing my shared screen? Any trouble? All right, Kevin's good. So 2, how about you? I still need to refresh or do anything for you? Just speak up. That's much easier.
Kevin was having trouble seeing the screen.
Okay, so how about now? You guys all set, right?
Yeah, I'm good.
All right. Okay, let's continue here. So what value we should consider or say calculate to find out the signal, DC or AC? What value? Anyone remember?
Average value.
Excellent, Josh. It's average value, okay? It's average value. So that's exactly why when we try to find the average value of this signal A, we find average value is 0. And the average value is 0 means there's no DC at all, okay? So this signal is purely AC. Purely AC. However, here's another thing you need to be very careful. Purely AC contains different kind of AC. Okay, yes, all AC, no DC. However, it including different kinds of AC. Okay, what does it mean by different kinds of AC? AC include fundamental component and harmonics. And let me summarize this a little bit in the notes. What I'm saying is this. DC and AC, right? Everybody understand this. What does DC look like? Flat line, right? DC itself just a little flat line. If you see a signal is not flat line, it's not only DC at least, okay? Because if purely DC is flat line, okay. What does AC look like? Sinusoidal. However, you need to be very careful. I mark it off. However, I still keep it on. AC contains different kind. The first kind is called fundamental components, AC, and the harmonics, AC. What's the difference? Fundamental AC means the AC with 60 hertz as frequency. That AC is called fundamental AC. Harmonics means the AC, also AC, okay, with otherwise frequency. Okay, so this is called the harmonics. However, both individually both fundamental individual or harmonics individually, sinusoidal. Okay, individually they look like a sinusoidal. However, if it's not individually, it's mixing together, what you're going to see is a very messy waveform, a very messy waveform. Okay, so this is a little bit knowledge about AC. If you already know it, or you kind of understand here this knowledge, that's fine. If not, that's okay too. I mean, because some of you haven't yet taken 335, so if short of this part of knowledge, that's fine. This course is not requiring 335. Okay, it's not about AC. It's about AC. Okay. So this is the signal concept, and then going back to our PPT slides here. What we're seeing of signal A is, first of all, as I said, we know this is not DC. There's no DC contained at all. However, look at the AC. This signal A is not a sinusoidal look at all, right? It's not sinusoidal look. Then recalling we just mentioned in the notebook. It means what? It means mixing rather than individual AC. Does it make sense? Because it's not sinusoidal. Not sinusoidal means it is not individual AC, but mixing. Mixing of what? Mixing between the fundamental and harmonics. Okay. That's why the conclusion here is it's AC, however, it contains fundamental and harmonics. Okay. And the harmonics, as we just discussed, are the ACs with otherwise than 60 hertz frequency. So how to find those harmonic components contained in this mixing signal? We can use Fourier Transform Fft. Fft stands for fast Fourier Transform. This is something you guys probably gonna learn from physics class and the CE 302. Okay. And this is a technique we use to find out each component mixed in the mixing total signal. So this is signal A. We move on to signal B, and the last lecture we also got a conclusion. It's shifted AC. So if you're looking for the average value, it equals to 1.5 volts. Okay. How we find the average value here? Can anyone have any idea how to find the average value of this signal B? I'm telling you the result is 1.5 volts, but how we get there? Anyone knows? You can speak out your idea, and then we can discuss from there. Any idea of the signal? Looking for the average value. Okay. How do we do it? How do we do it? All right, let's see. How about this? Showing. You can see the signal B, right? So let me write down how to find the average value. Average value of signal B equals to what? Anyone has any idea? How about 5 volts last how long? 0.01 second, right? Plus, so from 0 second to 0.01 second, this time interval, the signal B is 5 volts. And from 0.01 on to 0.02 seconds, the signal B is -2 seconds, at -2 volts, right? And after 0.02 second, what happened is the beginning of the second cycle, isn't it? So this is a periodic square wave. So how to find the average value? We just find the average value over one full cycle. That's enough, right? One full cycle, what's the cycle? Just a 0.02 second, isn't it? Because 0.02 to next the 0.04, I'm sorry, this is not 0.01, obviously. 0.02, 0.03, and then 0.04. From 0.02 to 0.04 is the second cycle, right? So we just over the first cycle, 5 volts lost 0.01 second, and then 92 volts lost how long? 92 volts lost how long? Anyone?
Same amount of time.
Same amount of time, exactly. 0.01. Very good. Exactly right. Divided by what? Total length, which is the period. Okay. So this is how we come up with 1.5 volts as the average value. Does it make sense? What were we doing? We were looking for the area here, minus the negative area here, and then divide by the time length. Of course, the average value, how to find, what is the generalized the average value equation? 1 over t integral over t, a function of t dt, right? This is the generalized average value equation. And since this is square wave, very easy. So integral, we don't have to go through it. We just need to use summation of 2 and then divide by this period, divide by this period. Does it make sense? This is how we got the average value. What's the conclusion? It's not 0, of course. Contains DC. By the way, what is the contains DC's value? What is the value of this contained DC? What is the value? A little bit tricky question.
Would it be the 1.5 volts that were shifted by?
Exactly. Nothing but this 1.5. Nothing but this. We just, a signal, a randomly given signal, mixing signals, average value is nothing but the DC contained. Okay. Let me repeat this again. So a randomly given mixing signal, the average value of this signal is equal to nothing but the DC contained. Remember this. So this is how we got the DC contained inside of this signal. And then keep moving here. As we know, it has AC and DC. Why it also has AC? Well, signal B is not flat line. Of course, it contains the AC. And AC, again, is not sinusoidal. Therefore, it contains harmonics. Right? And here it explained why we just explained why we got 1.5 volts DC. Okay? Just to find average value. Find average value. And then how to find AC components like the magnitude and the phase of the fundamental and the harmonics. Well, we just mentioned in previous slide, fast Fourier transform FFT. Okay, just remember this name. For now, you just need to remember the name. Fourier transform is used to find the each component. Okay. Now the second thing we need to review, as said, is a circuit analysis. This class heavily rely on the circuit analysis. Okay, so we need to recall everything we learned from circuit 1. Okay, recall everything we learned from circuit 1. For example, this is example 1. You're looking for I0 and Ix. So I0 is over here. Okay? I0 is labeled here, okay? Going through 3 kilo ohm. Ix is the current going through the 6 kilo ohm downwards. Now let's just do an exercise. Okay, we just look for the KCL. We don't have to find out the I0 and Ix value. We just need to come up with the KCL equations at V1 and V2 respectively. First of all, KCL means what? KCL means we are select one node to write the current, right? How the KCL is described? A current flowing into the nodes, the sum of the current flowing into the nodes is equal to total current leaving it. Remember? So if you select V1 and V2 to write KCL, what does it look like? How about these two? Give you guys 1 or 2 minutes to take a look at this equation, and then I will come back to explain. Let's have 1 or 2 minutes. Take a look at these 2 equations and think about them to see if they make sense to you. Okay. All right, let's take a look at these 2 KCLs. First one at V1. V1, how many currents involved in this regard this particular node? How many current? 3, right? 3 current. What are they? The current flows through 2K. The current flows through 3 volts voltage source and I0, which is flowing through 3K. Does it make sense? 3 current. Therefore, no matter what, your KCL equations is definitely 3 terms. No more, no less. This is the first thing. Second thing, to write the KCL, you must assume the current direction. Okay. So for example, we are assuming the current flows through 2K as this way, towards left. Okay, towards left. From right towards left, this way. And then assuming the current flows through 3 volts voltage source upward. And then this current is I0, which is labeled towards right, and we just keep using it, right? We need to assume the current direction, according to which we start to write equations. Which means if you assume different current direction, of course you're going to end up with different sign in the equation. But that's fine. That's not necessarily wrong. Okay, that's not wrong at all. So accordingly, let's talk about this current. Going through 2K. What's this current? How to express this current? We're expressing the current here based on what? Anyone remember? Ohm's law. What does it mean by Ohm's law? We are looking for this current, right? We are looking for this particular current. Ohm's law means the current here going through this resistor equals to the voltage across it divided by the resistance, right? Resistance value is given as 2K. But what's the voltage across it? And also be careful following such particular polarity. Why it has to be this polarity rather than the other way around? Why? Because the current direction is flowing downward. Okay, because the current direction is flowing downwards. Is entering the positive and getting out of the negative. That's why the voltage we need must follow such polarity. Otherwise, polarity is going to give you the otherwise reversed current direction. Very important thing. So now, what is this current? How do we express this current? Voltage divided by 2K. And then which voltage following this polarity? And also right across 2K. Which voltage? V1, right? It's V1. Nothing but V1. So this current should be V1 over 2K. Okay. Of course, by close, careful observation, you will see V1 equals to what? V1 equals to nothing but 3 volts, right? Exactly 3 volts. Right? You see 3 volts with this polarity is exactly parallel with 2K. You see these two? Exactly parallel, which means sharing the exactly same voltage with the exactly same polarity. So this term is nothing but the current here. And the following towards left direction. And then similarly, we take care of the second current here. The second current here, I naught, is our unknown, the one we are looking for. We just keep it. And both this current and this current, both these two are leaving the node, right? Leaving V1, the node. So these two sum these two together equals to, equals to the current, total current entering the node, which is this current. That makes sense. And then what is the current here entering the node? Be very careful. This is the current going through this 3 volt voltage source. When we see a voltage source, what's the current of it? Is unknown. Remember this. When we see a branch has only one voltage source, maybe dependent, maybe independent, no matter what. We cannot know the current. Okay, no way to know the current because this is a voltage source. You can only know the voltage value. You don't know the current. So you have to do what? Assume an extra unknown, I sub 3V. Does that make sense? This is how we come up with the first KCL equation at V1. This is how. Like I said, again, if you assume a different current direction at the beginning, of course, you're going to have a different sign here. However, it's going to be same equation. Okay, it's going to be same equation. It won't bother. Either way works. Either way is right. Okay, either way is right. The point is you assume your current direction and then you're writing equations sign, current term sign, exactly following that. Exactly following the assumed direction. Okay. And then go to the V2. V2 has 3 currents involved as well. 3 currents involved as well. And the current here going through the 3 kilo ohm is I naught and towards right. We don't even need to assume. But the current here going through this dependent source is what? Oh, by the way, this dependent source is what kind of dependent source? The voltage dependent voltage source, voltage dependent current source, current dependent voltage source, or current dependent current source. 4 types, right? So this is what?
Current dependent current source.
Excellent. Current dependent current source. Why is that? So first of all, you're saying current dependent. Why is that?
It depends on the IX value.
Excellent, because the value is in terms of IX, which is a current. That's why this is called current dependent. And then you're saying is a current source. Why it is current source? Kevin?
Oh, yeah. My audio cut out for a second. The arrow in the diamond means
excellent.
Current.
How can you tell this source? Is relying on the look, relying on the symbol, circuit component symbol. It's an arrow rather than what? Polarity positive negative. That's why this is a current source. And also this is a current dependent current source. Very good. Very, very clear logic. Okay. Is being able to judge those 4 different kinds of dependent sources is very important and also very basic in our major. Therefore, this is a current source, and we are very happy because current source can tell the current value. So this current here is 2Ix towards left, entering the node V2. Okay, so 2 currents entering the node, and the third current here is what? Ix itself and leaving the node, right? So sum these 2 currents up equals to leaving current Ix. And this is how we end up with this current, how we end up with this equation. Any questions regarding this KCL? It's involving the source, involving the dependent source, involving the resistor. Any questions? Any is it also something a little bit rusty? Any questions? All right, if this is fine, then we can move on. And if we trying to solve this, these I naught and Ix, take a look at these 2 equations. What's the problem of them is how many unknowns? 1, 2, 3, 3 unknowns, right? 3 unknowns, 2 equations. What does it mean? It means you can't find any one of them. Does it make sense? It has to be same number, remember? This is the algebra knowledge, I think. So what you can do? Come up with more equations. Come up with more equations. And here, relying on this dependent currents Ix, you can come up with one more equation. Like current Ix is the current through 6K according to the Ohm's law. It equals to the voltage across 6K divided by 6K, right? The voltage across 6K is nothing but V2 itself. And unfortunately, you are introducing one more unknown. Wow, my gosh. So what can I do? Come up with more equation, right? Come up with more equation. What equation you can come? Is again, Ohm's law regarding I naught. I naught is the current through 3K. So it equals to the voltage across 3K with this polarity divided by 3K. The voltage across 3K is equal to V1 minus V2, right? This node V1 minus this node V2. This is the voltage across the 3K. As I said today in the lab, two-terminal concept, right? Two-terminal voltage potential difference is the voltage. So with this polarity is V1 minus V2 rather than V2 minus V1. Okay. Because this polarity must be followed. And why we have to follow this polarity then? Because I naught is going towards the right. It's going into the positive and get out of negative terminal. That's why we need to follow this particular polarity. So V1 is 3 volts minus V2 divided by 3K. 4 equations, 4 unknowns. Does everything make sense? Any questions regarding this circuit 1 knowledge? I have taught 235 circuit 1 twice, and my experience is 235 as the very first major course is actually scary. I'm using the word scary. The difficult level is high. Is actually high. However, the tricky thing is once you climb over this mountain, you will see like a very plain, very nice forest or landscape. Much easier. You'll find everything much easier. It's understandable, absolutely doable. And this is a trick of this major, I would say. Okay. But there's no way to delay the circuit 1 knowledge to later, like a 400 level course. No, there's no way to do that. So I'm seeing circuit 1 is actually very scary and terrifying many students. But the knowledge is the basics. And once you can climb over this mountain, everything is doable. Everything is reasonable, logical. It's smoother. It's smoother. Okay. If this is fine, and then let's see the result. Actually, 4 equations, 4 unknowns. You're able to find any one of them. And what we care is just the I naught and Ix, and turn out to be positive and negative 1 milliampere. Okay, that's the algebra thing. Exactly same circuit. Let's exercise the KVL. I'm using the green color to providing assume the rotation direction, and accordingly, let's try the KVLs. 3 KVLs in 3 meshes, obviously. How about I give you guys 5 minutes to write this yourself, to really exercise this out. I will come back in 5 minutes to present the solution, and then by comparing your answer and my solution, we can have a Q&A. Okay, 5 minutes. Go ahead. All right, let's take a look at the solution here, okay? Loop 1, loop 2, and loop 3, 3 KVLs presented here. Any questions? KVL, it means what? KVL means inside of one closed loop mesh, the total voltage across the total voltage across all of the components equals to 0, right? So to loop 1, you have 2 components, therefore 2 voltage terms. Loop 2, you have 1, 2, 3, 3 components, therefore 3 voltage terms. Again, voltage terms, okay? Voltage terms. Third loop, you have 2 components again, so 2 voltage terms. However, each voltage term might be in terms of current. Don't be confused. Don't be confused. They are absolutely voltage terms, however, it might be in terms of current. Okay. Any questions? Any details? I can explain more. Any details? Any term, any voltage term you want me to explain? All right, if no direct question, I just pick this term to talk about. Pick one. This term. How we come up with this term? This term. This is the in loop 2. Okay, this is in loop 2. Inside of this loop, following this rotation direction, you're trying to find out voltage here with this polarity. And then what do you do? Following the Ohm's law. 6 kilo ohm times the current through it equals to the voltage across it. Resistance 6 kilo is given. Then what is the current through it? Downwards. Not upwards, it's absolutely downwards. Why? Because the voltage polarity here, we are assuming is like this. Same as the rotation direction. The rotation is come across the positive first, followed by negative. So the voltage you're looking for must follow this polarity. And therefore, the current you're looking for is downwards. What is the current downwards flowing through the 6 kilo? What is it? IX, no problem. It's IX, no problem. And there's no mistake if you say it is IX, no problem. However, if we are not considering this IX, just purely based on our memory about the mesh or say KVL, what do we say? Current in this loop is what? I2, right? Remember, we define I2. Current in this loop direction like this, upward, we define it I3, right? But what is the current downwards going through 6K? It equals to I2 minus I3. Does this make sense? And I2, I3 are respectively mesh current in 2 and 3. And the next, what matters is who is equal to I2 then? I naught. Does it make sense? I2 is nothing but I naught. Okay, it's equal to that. And I3 is what? Equals to what? 2IX? Is that right? Anyone? Any opinion? I3 is equal to 2IX. Is that right?
Negative.
That's right.
Excellent. Excellent. Kevin is got a point. I3 is, well, we should use 2IX. That's true. However, it's negative 2IX. Look at the I3 direction, downwards here. because it's counterclockwise rotating. 2ix is what? Upward. I3 equals to negative 2ix. Therefore, I2 minus I3 equals to what? I0 plus 2ix. This is how we come up with this. So this is one term here. I'm explaining in detail. And once again, if you count 3 equations and the 1, 2, 3, 4 unknowns. So you need more equations. More equations, you might have different equation pop up, but what I'm using is, again, dependent source Ix equals to V2 divided by 6 kilo ohm. So 4 unknowns, 4 equations. You're able to find the same answer as a previous example. Obviously, as you know, KVL, KCL are what? Alternative, right? Alternative. One way or the other. According to which is easier, you can decide which to use. Okay. So this example 1 is purely about the KCL and KVL, mesh or nodal, if you prefer that name. Okay. Any questions? Any thoughts? Any comments? Any details you want me to talk more? Anything? All right, if this is fine, then we move on again. Example 2. Use Ohm's law and KCL, KVL laws in the circuit to find A. Question A is Vx. Where is Vx? Okay, here. My Vx is here. What's the voltage here? B, what is I in? I in is over here. C, is over here. D, the power provided by dependent source, the power of this guy. This is the only dependent source you have in the circuit. How to do this? How to find Vx? How to find Vx? Actually, this circuit is actually very straightforward. To find Vx, we can choose because Vx is a voltage, right? To find a voltage, maybe our first impression is using KVL or KCL to find a voltage. KVL, right? The first feeling or first think, right? Because the KVL is full of voltage. So you can find a voltage, maybe. Of course, it might be wrong, but your first impression, the first think might be KVL. Okay? So, and also we're seeing there are a couple of voltage across different components are already provided. What can we do? How about just to choose this loop, the red color loop? Of course, and let me close it. This loop, starting from this node, which is ground, rotate counterclockwise back to this node. How about this? And inside this loop, how many voltage you are going through, actually? How many voltage you are going through? Anyone? In this loop? How many voltages? Because we have decided to use the KVL. KVL means the sum of the voltage along this path is equal to 0, right?
3.
3, very good, very good. 3 voltages. One is obviously 2 volts, another is 8 volts, and the third one is our Vx, the unknown. To sum them up, according to polarity. Okay, this is very, very important. Must according to the polarity, and then you end up with the one equation and with one unknown. Take a look at this equation, and does it make sense? You're rotating from here, and then you come across the negative of 8 volts first. Therefore, it's negative 8. And then you come across negative of the Vx, then it's negative Vx. And then you come across the positive of 2 volts. That's why it's positive 2. Summation is 0. Right? So Vx turned out to be negative 6 volts with this labeled polarity, of course. Voltage polarity and the current direction, very, very important. Very, very important. Any questions? Any thoughts? All right, if this is fine, then we can move on to find IE. IE, as said, is here. IE equals to what? Well, this is current. We might think of KCL. IE is the current going into this node. Does it make sense? We call this as what? Supernode. What is supernode? We are seeing a line or with 3 dots. Actually, there's a single node. No matter how big you sketch it, right? No matter how big it looks like, it's a single node. One voltage, identical voltage potential on them. So if you're writing a KCL at this node B, I call it node B, like this, you can find IE. Similarly, if you write a KCL at node A, you can find IS. Meantime, remember, Vx has been turned out to be negative 6 volts. Okay, that's is considered as known. Now I give you guys kind of 3 or 4 minutes to calculate IE and IS respectively. 2 KCLs should be able to do the job because this is very straightforward. 3 or 4 minutes should be enough. Okay, give you guys that amount of time and then come back to I have you present the solution. KCL at B to find IE, KCL at A to find IS. Go ahead. Just a little bit reminding, okay? This is synchronized live lecturing. So when I say do some exercise, really do it. Okay? Please really do it. Please take it seriously because it's a very, very efficient and effective way to learn something and therefore do good, do well in the exam. Okay, this is the very, very important part of the class. Okay? So So really do it. Really try the very best. You might kind of not be able to write a lot, not be able to come up with the right equations or answer, but that's fine. That's how we learn new things. Okay. Well, even though this is a reviewing something, but still, the bottom line is to really try and try hard. All right, let's see the solution here. It's not a difficult equation. It's just a one unknown and one unknown, one equation, one unknown, another equation, and then we find the answer. Of course, again, Vx is equals to -6. We just find it. Okay, this is the equation here. One KCL at A, another KCL at B. Take a look to see any questions. 4 currents involved in this KCL, and which current term do I need to explain? Anything like that. Also, second node B, we also have 4 current term. Okay, which any term I should explain? Anything like that? Any questions? Any questions? All right. Let's just pick one. This term is which current? Daniel, what do you think? Daniel?
It'd just be the top branch of the part in between the nodes.
Any other answer? Say, Drew, what do you think?
I'm not really sure.
Drew, what do you think? This particular term is which branch's current?
Which one are we talking about?
This one. I'm circling it. This is a KCL equation again. All of these terms are actually current terms. So this particular one is which branch current?
It's top branch.
No. Kevin, what do you think?
The dependent current source over on the far right.
Excellent. Here we go. Here we go. In other words, what is the current here? What is the current here? Ohm's law. Voltage cross it, divided by resistance value. So Vx over 4 is the current here. Is, of course, we know is labeled here. Current here. 8 divided by 2, we also know this is Ohm's law, the current here. Downwards. 4Vx is the current of this branch. Okay. 1, 2, 3, 4. 4 branches, 4 currents. And the current here is determined by this current source. This is a voltage-dependent current source, right? It's telling you the current value, which is 4Vx. Does it make sense now? Any other questions? All right, we can move on here. Next, we got Vx, In, and Is. The last one is the voltage. I'm sorry, it's the power. It's the power of this guy. Yeah, the power of this guy. The power of this guy is simply equals to the product between the voltage and the current of it, right? The current of it, again, is what? The current of it is what? 4Vx. Okay. This is the, again, basic knowledge about dependent source. The current of this dependent source is 4Vx. What's the voltage of this guy then? Anyone knows? What's the voltage across this guy? Excellent. 8 volt. Right across it. Right? Connor got the correct answer. Good. Shane's good. 8 volts right across it. So 8 volts is the voltage with this polarity. Again, it's about a polarity. Okay, it's very important. And the current is 4Vx upward. The product between two is equals to power. However, you need to be very careful. This current is what? Is leaving the positive polarity and entering from the negative polarity to voltage. Therefore, what happened? Negative power. Does it make sense? Remember in the circuit 1, we learned we might end up with the positive current or positive power or negative power, respectively meaning what? Positive power meaning what? Negative power meaning what? Anyone remember? Positive power means
it's either
Is it
absorbed or supplied.
supply?
Any other answer? Any otherwise?
Absorb.
Absorb, or say consuming. Okay. Positive power means consuming or absorbing. Negative power means supplying. Negative power means providing and sourcing, or say. Yeah, Connor using a sink and source, that makes perfect sense as well. So positive power means what? Sinking. Negative power means sourcing. Good. Very good. Very good. Okay. Remember this. It means the opposite way. Okay. This is the example 2. Any questions? Any questions for example 1, 2? Anything? All right, if this is fine, then we can move on. Now here, I have notes here. Negative power means this dependent source is sourcing power, providing power. Okay. Here, example 3, I'm using the red color to emphasize the importance of the example 3. It's a typical electronic circuit analysis. What I'm saying is what? What do I mean by typical electronic circuit? Look at these circuit as well as example circuit. The problem of these circuits is you're seeing clear loop. You're seeing clear closed loop, or say mesh. However, in the real circuit, in real practical circuit design, You barely see loops. Okay, there's nothing closed. Very confusing. Let me give you some example. Move on to the dock camera. Example 3. Okay, it's on your notes. The first circuit we're going to deal with looks like this. This is a typical electronic, very practical circuit diagram from where you can see something like this. Something like this. Something like this. Okay. From where you can't see a loop, there's no closed thing at all. However, this is nothing but a closed circuit. Closed circuit. Because otherwise, open loop, right? Open loop means what? Anyone knows what does mean by open loop? It couldn't be open loop because open loop. Say that again, Josh.
Infinite resistance.
And therefore, what's the consequence?
Zero current.
Excellent, excellent, excellent. If it is really open circuit, the direct result is there's no current. There's no current. This circuit is useless. What would be here using a zero current circuit for what, right? So they couldn't be. It's not. However, from the look, we're not seeing any closed loop. So we're not seeing closed loop. So what we are learning today is how to deal with such kind of circuit, or say how to apply the KCL and KVL on such kind of circuits. Okay, this is what we learned today. Let's do exercise again. Let me give you a couple of minutes. All of you guys try this out. Find I naught and V naught yourself. Find I naught and V yourself. Try this for 2 or 3 minutes yourself. Let's see where you can reach. Okay, 2 or 3 minutes. Really do it. Okay, really do it. All right, folks, let's see the solution here. Anyone got a V naught value? Anyone got a V naught value? or I naught value? Anyone got anything?
I think so, but I'm not 100% sure if I did it right.
Well, of course, everybody is same. So feel free to let us know.
I got the 0.7 volts for V naught because
That's the
right-
correct answer. Yep, very straightforward. That's right. How about current?
0.215 milliamps.
Excellent. Kevin, of course, got the both V naught and I naught correctly. But let's see how to reach there. How to reach there. Okay. What I wanted to introduce is so-called. In my way is so-called what it called the from top to bottom KVL, or say the path KVL. What does it mean is this? You're not seeing a loop. That's okay. I don't care. I'm just to take this path. This is one path, right? Now path, I still can write KVL. How to write this KVL? From the top to bottom to write KVL. How to write this? From the top point is 5 volts, right? You got it. The top point is 5 volts. Bottom point is what? 0 volts, of course. It's ground. So total from top to bottom, the total voltage is equals to what? Top 5 minus bottom 0. Doesn't make sense. Total voltage drop is top 5 minus bottom 0. Doesn't make sense. And this total voltage drop equals to what? The voltage summation among all of the components through this path. Doesn't make sense. In other words, along this path, only 2 components. One is 20 kilo ohm resistor, and another is 0.7 volts voltage source. So the voltage across them, the sum of them equals to 5 minus 0. Does this make sense? If it does, then go ahead. 5 minus 0 equals to what? 20 kilo ohm voltage equals to what? Again, you still need to follow this polarity, okay? The 5 to 0 rather than from 0 to 5, so it's going downwards, then your voltage here must be positive at top, negative on the bottom. Same here, positive on top, negative on the bottom. So 5 minus 0 equals to voltage across 20 kilo ohm, which is equals to Ohm's law. 20 kilo ohm times I naught equals to the voltage plus 20 kilo ohm with this polarity. And then plus the voltage of voltage source, which is the easiest part, right? We really like it. And also follow such polarity, then it's nothing but 0.7. And then what do you see? One equation, one unknown. Sorry. .215 milliampere. And of course, V naught is very straightforward. We should be able to see V naught means from this node all the way down to the ground, 0. It's nothing but this 0.7. Right? It's nothing but this 0.7. From this node to the ground, the same as from this node to the ground, right? So 0.7. Right? This is the first circuit. I'm applying a so-called from top to bottom path KVL. It works. Top is a node, okay, the bus. The look is called bus. It's 5 volts bus, means the node along this bus, this bar, is equals to 5 volts potential. Okay, this is path KVL. Of course, how we justify this is not open loop at all. There's a loop. First, the current through this path is not 0, so definitely it's not open circuit. It's not open. Okay. Second, we can do what? We can do equivalent. So this circuit is equivalent to what? What kind of circuit? let me do an equivalent so that you can tell actually this is the circuit we know very well already. 5 volt, the bus is equivalent to what? Does this make sense? 5 volts bus means nothing but this guy in red color. This is the trick of this path. Does it make sense? 5 volts on the top means the positive, the longer bar is 5 volts, positive terminal. However, any voltage is what? 2 terminals concept. Remember, this is the 3rd time today I emphasize this. Voltage means 2 terminals. The second terminal, which is a negative polarity of the 5 volts, is nothing but the ground. That's why I shorted it down here. And once you short it down to here, you are seeing a loop from where you feel free to write KVL. Is it clear now? Did I make everything clear? Anything? Thank you. Thank you too. Thank you, Connor. Nice, very nice. Thank you, Shay. All right, this just remember this path KVL, and we will apply the same concept, same way, same method on 2 more examples by next Thursday. Okay. All right. Thank you for attending the lecture, and talk to you, or actually see you guys. See you guys next Thursday. All right. Bye now.